Child throws a stone into a lake, causing a circular ripple to spread out. The radius of the circle increases at a rate of 0.5 feet per second. How quickly is the area of the circle increasing when the radius is 30 feet? Now, it's a long time since we've ever done any modeling of problems ourselves, so we're probably going to need to take a little refresher. The first thing you'll do is to identify the quantities that are involved in this, and those are going to be the radius of the circle. So what we'll do is we'll write down very clearly what each of those are. So let R represent the radius of the circle, and the other thing that we're talking about here is the area of the circle. So let A represent the area of the circle. Okay. And it's a good idea to set out at the start exactly what your variables are going to represent. Now, in the past, when you've been modeling real life situations, they've been static. So R has stood for a certain number, A has stood for a certain number, but in this case these are changing. In calculus, things are changing all the time. So R doesn't have a fixed value except at a particular point in time. Well, the first thing that we said to do was to write down the given rate and the required rate. Okay, so the given rate here, what is changing? The given rate. The radius of the circle increases at a rate of 0.5 feet per second. Now we have to write that as a derivative. So the radius is the thing that's changing, and it's changing with respect to time. Okay? Because the unit is feet per second. So it's a radius with respect to time. So the way we write that is we write it as dr dt is equal to 0.5 feet per second. Okay, so this is something we're going to have to get used to. If R represents the radius, then the rate, the speed at which that's changing, is given by dr dt. The required rate, or the desired rate, the one that you have to find, comes from the last sentence. How quickly is the area of the circle increasing? So it's the area that's changing, and you want to know how quickly that's changing. So if A stands for area, dA dt stands for how quickly that is changing. Okay, so please try and remember that. You already know it, it's now just a matter of applying it. That the derivative of a quantity, dr dt, dA dt, tells you how quickly those quantities are changing. Okay, so those are our two rates. There's no need for a diagram in this situation. You just have a circle that's growing in size, so you don't really need a diagram for that. The next step, though, was to write an equation that relates the variables that appear in the given and desired rates. So the variables that we're talking about here are the area and the radius, and we're talking about a circle. Remember, this is the area of a circle. So the equation will come from the formula for the area of a circle, which I'm going to assume you know is A equals pi r squared. And now we're going to differentiate that with respect to t. Differentiate with respect to t. So the way you do this is new. Differentiate A with respect to t gives you dA dt. And then if we differentiate the right hand side, pi is a constant, r is squared. R is a variable. So when we're differentiating the variable, we multiply down by the power, because it's a polynomial, multiply down by the power, reduce the power by 1. So that's going to be 2 pi r. But now, and I'm going to put this in a different color simply because it's something that we haven't ever done before. It's going to be 2 pi r, but now since we're differentiating with respect to t rather than r, it's going to be dr dt. Okay, and that's the new step. Every time we differentiate a variable, we will differentiate it normally, but we'll attach d, in this case r dt. Whatever the variable is, it's going to be d of that variable dt. Okay, so that's the new step. Okay, so this is the step where you have to be careful. Okay, this is brand new. Alright, from here on in though, it's not It's not too difficult at all. Now we can substitute. You substitute after the differentiation. Okay. Substitute after the differentiation. Now, dA dt is what we were trying to find. dA dt equals 2 pi. Now to find r, you have to go back and read the question again. R is changing, but you have to find it at a particular moment. And if you go back and read the question, it says, how quickly is the area of the circle increasing when the radius is 30 feet? So the radius here is 30. So r is 30. And dr dt, if we look at dr dt, was 0.5. Okay, so multiplying that out, dA dt will give you 2 by 0.5 is 1, so it's just going to be 30 pi. Now get your units right. The radius was measured in feet, and since this is area, it's going to be feet squared per second. Okay, so there is something new in here. The new piece, once you've got your formulas together and your equations together, the new piece is to remember to attach d dt to whatever variables you differentiate. Okay, hope that was okay, and watch it again a couple of times to make sure.